Hello, hello, hello. I am the red, green, blue, and yellow text reader. This is Chapter 8 Energy, just a short and sweet review. When a constant force moves an object in the direction of the force, the work done equals the product of the force and the distance the object is moved. So that's just setting up the definition of work, product of the force and distance. Okay, so work is a measure of energy, okay? And work is how you get the job done. If you're trying to get something done, you need energy to do it. Power is is the rate at which work is done. So if you have a car that has twice the power of another car, both can get you from here to there, but the more powerful car can get you there faster. The rate at which work is done. Now, 90% of the time, the rate is per second, but that could be any unit of time, minute, hour, century, whatever. And so those are two separate concepts, power and work. The energy of an object enables it to do work. So something has to have energy available to it in order to get work done. Speaking of energies, mechanical energy has two parts. One part of it is the energy that is due to the position of something, and that's what we called potential energy, PE. And when we say position, most of the time we're talking about gravity. So if you raise something up, then you are doing work against gravity, and once it's up high, now it has potential energy. It has energy that you had to do the work to raise it up there, and it has the potential to fall back down. And if it fell back down, that potential energy would turn into the movement of it. So the other part of mechanical energy is the energy due to the movement of the object, and that is called kinetic energy, KE abbreviation. Now, like I said, this is just a big picture, short and sweet review. So I'm not going into a lot of detail about potential and kinetic energies. The law of conservation of energy states that energy cannot be created or destroyed. It can only be transformed from one form into another. So that seems, to most people nowadays, that seems kind of obvious. But when this was first discovered back in the 1800s, they didn't know how all these things worked. And it was a really big deal when they saw that this idea of energy is everywhere and it only ever changes form. So that means that, like I said there, you can have potential energy turn into kinetic energy, and it can turn into chemical energy, or there's lots of different energies. But it's all just getting recycled. One energy moves into another thing and moves into another. That's the law of conservation of energy. Then we switched over to machines. A machine is just a device used for multiplying force or changing the direction of a force. When I say multiplying, I mean it could get bigger or smaller. If you multiply it by a number less than 1, then the force gets smaller. Maybe I should change that word multiplying. Oh, and 3 classic examples, the lever, the pulley, and the inclined plane are all simple machines. And we talked about all the different machines, simple machines, in the notes. Then we also talked about the useful work output of a machine is less than the total work input. So if you put work into a machine, you're going to get less work out, mostly because there's friction along the way. There's no such thing as a frictionless machine. You never get out everything that you put in. And that's the summary. Let me know if you want me to go into any more detail about anything else. If anybody has a question that you want to see a homework problem explained, I'm happy to do that. Thank you.